let me start the webinar. And thanks for joining, guys. And this is Shyam from business team of GeoPits. And let me shortly brief about GeoPits, guys. And we act as a DBA partner in a data platform. We help to manage the database services in 24/7. We got Microsoft partner in data platform, and our partner GeoPits are Microsoft, NewsGen, and we got recently partner with MongoDB as well. And we got 100 plus clients through all over India. And in GeoPage, we got 45 plus employees, and we are very proficient with Microsoft, MySQL, and MongoDB as well. And any type of database, we are GeoPage are really there for to help you guys. And this is a briefly short about the GeoPage. And I want to introduce the speaker of the webinar, Mr. Manoj. Here he is a senior DBA of GeoPage, and he have done a several projects in a DBA and database, and he's very proficient in DBA also and MySQL also. And the topic of the webinar is SQL Server 2022 and streaming database administration for the modern environments. Yeah, I think Manoj, you can take it from here, Manoj.
Sure. Thanks for the introduction. So, let me share the screen so that we can start.
Yeah, sure, Manoj. I make a host for you. Yeah, you can start it.
Yeah, fine.
Yeah, thank you.
I hope my screen is visible.
Yes. Yeah, Manoj, your screen is really visible. Yeah, you can start the webinar.
Yeah, thanks for coming.
Yeah, sure.
Yeah, good evening, everybody. So join this evening. So myself, Manoj Kumar, DB engineer, so working in GeoPits. So today's webinar session is all about like a SQL Server 2022, so which is streamlining the database administration for a modern environments. So our agenda of this meeting, like webinar, so what is the next step for SQL Server? The overview of SQL Server, which is in 2022. In 2022, which we have that intelligent query processing. So having the parameter sensitive planning along with DOP feedback, degree of parallelism, cardinality estimate feedback. So first thing, so what is the next step of the SQL Server, which we have? So here the short intro of that, how it emerged and how it become more enhanced in the SQL Server to make a very much optimal level of providing all the products here. So in 2016, there was an query store they have been implemented. So along with that, all this encrypted row level security with that, all that additions of this area. So next with that, 2017, which we have that containers along with that adaptive query processing with the machine learning services, which they have provided. So in recently 2019, they have given like data visualization along with that accelerated database recovery, which is quite impressive here. So with that, along with that intelligent query processing stuff. So in 2022, like the overview of 2022, so what is that mean? So it is that business continuity through Azure. So here majorly that it should continuously replicate from that data from the cloud. So end-to-end connection, so will be more proper here. So and another thing which is that seamless analytics over on-premise operational data. So it's a breaking wall between operational and analytics tools using Azure Synapse for this. So another thing which is that visibility over your entire data, which includes that Microsoft Purview integration. So mostly into that data governance, all this stuff. So here come the security. So here MS SQL is a most productive and providing that great security among all the products since past 10 years. So use that immutable ledger to protect data from the tamperings with the intruders. So Next thing, which is that industry-leading performance with availability. So here is the built-in query intelligence along with that accelerate query performance tuning with the no-code changes. So our main aim of this session is to see about this query performance. How would you tune without any changes? So before knowing that intelligent query processing, first thing you should know about the query store. So what is that query store? I will explain. So here is a challenge. While tuning the expensive query, that will be time consuming. That's one of the biggest challenge as a DBA we are facing. So here in 2022, the query store on the default for the enable for the new databases. In the previous version, we used to have that option to enable and disable all the stuff. So while creating in the 2022, so you will have that option as a default. You can, while creating the database, new database, you have that option. So query store supports that read replicas from the availability groups. So along with that, no code changes will be involved. So you can be fine-tuned with the queries using that very processing mechanism they have implemented. So mostly intelligent query processing will reside on the query store. It will get some of the hints and feedbacks. Accordingly, it will work together. So this is a general emerging of that intelligent query processing, how it will come over that. So like based on that versions, here are the some of the architecture chart. So mainly in session, we are going to discuss about that parameter sensitive plan optimization, along with the degree of parallelism feedback, cardinality estimation feedback. So degree of parallelism feedback and cardinality estimation feedback will depend upon the query store hints and their feedback. So what is that intelligent query processing? The next gen, which is mean that of a 2022. So, and then why should you need to upgrade for the 2022? So here is a sum of the points, which is that it will give you that approximate percentile versions for that thing. So along with that, optimize plan forcing with a compile step of forced plans and reduce compilation overhead. So in the previous versions like a 2016, and also you will have that such options like a memory grant feedback percentage and then persistence. So here comes that new thing. So which is that mainly on the parameter sensitive plan, which are cater multiple query plans with the same parameter statement. So mostly here it will save the parameter sniffing. So the cardinality estimation feedback, which is loop that more choices, it gives that auto use query and give the hints. So in the degree of parallelism feedback loop for the degree of parallelism for the specific query and also adjust the query without recompilation. So every time we should not go with the recompile option, so it will automatically do that. So here that parameter sensitive plan optimization, the short intro of that I just want to go through. So here is that we have that plan sniffing problem. So mostly we have that parameter sniffing. So that scenario which is catch plan parameter query not optimal possible incoming parameter values. So I want to show that example. So while you are executing the procedure within one set of parameters, so like a minimum value of parameters you are executing, so the plan will be used to have that seek value. So next you are executing with that same procedure with a different parameters like a more than value. So it will use to have the scan in a plan. So again, you are executing the same procedure, which is previously used with the minimal value. So it will take that previous plan page. So it will gives you the scan. So here is that degradation of a performance will rise. So for parameter sensitive plan optimizations will improve this. How it makes sense. So you are executing the procedure one with a minimal value, it will take that seek plan. So if you are executing with a procedure value with a maximum, so parameter, so it will use to take the scan. It won't take that previous thing, so which is residing in the plan cache. So BSP optimizations enable using the database commutability 160. It will automatically enable multiple active caches, plans, parameter statements. The cache execution plans will accommodate on the different sizes, which is the customer providing the runtime parameter values. We can brief for both the parameter values on the later part. So like we quickly jump into that demo session. So here I have chosen that PSP databases, which is that all the stocks and the items which is storing. So I have generated and populated all the data previously. So these are all the data I have populated, and then along with that I have created a procedure. So here I'm going to check that whether this database in that which compatible. So here we are having this in a 2016 version, not a problem. So I'm just going to change this compatibility to 150 means 2019. I'm clearing the procedure here, which is already there. So, and also clearing the query store. Yeah, good. So here, so I have been using that procedure, that warehouse get stock items by supplier with a minimal parameter value like a 2 and another which I have chosen like a 4. So here I'm going to enable that param execution plan along with this. So I'm executing this query. So it executed within a millisecond. So can I see this? No problem. Yeah. So here it takes like a index seek along the key lookup. So because we have provided the minimum parameter, so I'm just running that second query which I have been kept here. So it will take some time. Yeah. So yeah, if you see this, so here it looks like a scan. So because we have provided that different parameters, so it takes a scan. So again, I'm rerunning this query whether we check it's taking that which plan from the which plan which see it should not take that the previous one. So before it was it looks like a index C. So now it takes the previous plan which I have done for an supply parameter with the 4. So this is a bad plan. So it will make a huge degradation of the performance. So I am clearing that cage. We can change the compatibility to 160, means 2022 versions. We will validate that. So how we perform. Here you can see that the CPU time just take more drastically increase. Before it was like a 3 millisecond, or it was like a 140 millisecond execution after the execution. Probably it will took around like 3 minutes for another. Now, if we will post this recording after the session, so I'm denying that request right now.
Yeah, thank you. No worries.
Yeah, we got it. So yeah, it's the same thing because so we fixed that the previous things also. So that's why I'm feeling. So now I'm just going to change the compatibility. So which is let's see, now it should be. And we are in the procedure as well as the policy. So I have changed across everything. I'm going to run the same query, which is with the same parameters. So import execute that within 7 seconds. So here we got like an index seek along with the key lookup, which is the parameter depends upon the parameter which you have given. So now I'm going to run with the 4 value of the parameter. Okay, so we got the previous things, so like a cluster index scan. This is unacceptable for this query to like this procedure to run. So now I'm going to execute this again. See, in previous case, like we got that old plan which is in the cage, like the index scan happened before. Now see that which is most adaptable here is that index seek. So it took that index seek and it ran the query fast as much as possible. Fastly. So this is an parameter sensitive optimization, so play a role here in 2022. So this will give you the great improvement in that query processing. So to upgrade this. We'll jump back to the slide. So here this predicate selection is one of the things which is applied here. So during the initial completions, we evaluated most parameters predicate out of 3. So I will show some charts so in the upcoming slide. So the first version is scoped to equality predicates referencing the statistics covered in the columns. So where that conditions which you are applying. So along with that, it will use to the column statistics system to identify the non-uniform distributions. So basically the statistics would have like a header and then density vector with the histogram. So mostly it will refers to the histogram and it will show you that how to perform. So predicate cardinality range. So at the runtime of the cardinality, each predicate value is based on the runtime parameters which we are giving. So here it will dispatcher will bucketize that cardinality values into the 3 predicate cardinality ranges. One is that with the low, medium, and high cardinality ranges shown in that diagram, which is here. So here that dispatcher plan. So the middle one, which is that variant, the Korea variant, which is belongs to like within a 10K to 1 million values, so that it will use a scan plus medium memory grant. So if it is less than 10K, it will use a seek with a lookup and small memory grant. So as we see in previous demo, which took that I have given that a minimum value like a 2 for the store procedure. So it took the seek and lookup. So after that, I have given, as for that value, so I have given the 4 is somewhat a maximum. So parameter which has been setting to that procedure. So here it looks like a scan and that large memory. So one thing consideration here, if we generate too many plans, we could create a cage board. So there may be a bloat can happen in the plans cage. To overhead this plan of PSP optimization must not outweigh the downstream benefit. So we have to set on that predicate value to that how much long it should be performed. So that would be helpful to avoid that such kind of a bloat. In next week, we jump into the degree of parallelism feedback. So here the degree of parallelism, so which is that parallelism is included for reporting and analytic queries. We used to have that large volume of data. So based on the data, so we have to spend a lot of with the parallelism things. So in SQL 19, so we used to have the max degree of parallelism with the option. So scope to configuration was set as 0 as much as the processor which we providing. So it was occupied that. So the major thing which we need to see is that determining of optimal max DOP setting in the manually adjusting for query is still challenges for us as a DBA. So here that new feedback mechanism will help you to resolve this issue by providing the feedback of the HTOP on the query level basis. So you no need to touch the code. So it will automatically send a feedback. So according to the feedback that it will was a plan and it will do that, it will occupy the processor as much. More DOP, more threads equal to more CPU. So less DOP, less threads equal to less CPU. So here is a simple architecture of the DOP feedback. So what is that it doing to getting a query from the query processor? So first it will check whether it's eligible and provide a feedback. According to that, it will validate and it will show that whether it's to be stable or revert, and it should give the how much value of the feedback need to be provided to that query store. According to the query store, the plan will be hit into that processor. So accordingly, we will get the execution as much fast. So this is how it works. Like identifies the inefficiency of parallelism and repeated queries by analyzing the elapsed time with that excluding that it will not include, it will exclude that buffer latch, buffer IO, and the network IO weights, all the things. So we will jump into the demo. So here I have already created the database for importers and I have populated the data as well with the values. So as well as I created that procedure, and here you can able to check all the feedback which you are getting through extended events. You can create a one feedback thing. So in that event session, so you can able to monitor that feedback which is providing on the live mechanism. So first I need to check the compatibility. What is that? Yeah, it was a 19 version. So I'm going to change it to the recent one. So just first thing first, I have enabled the query store for this database. So I'm clearing the cache, all the things in query store and changing the compatibility and the compatibility has changed. Yeah, done. So I am checking whether any data is there. So still no, I didn't execute any procedure as for now. So here I'm going to execute this procedure with the value set of parameters for. So let's monitor the let's calculate. So It will take time. So I will shortly show that how it capturing, then how we can validate the thing. So how we processing that max DOP to the live data. Still, we didn't get any execution because it's executing. I can also able to check using queries. So, yeah, no, still it will take some time. Just running the procedure on stress. We'll see some impact with live data execution. Yeah, here actually we got a feedback for the query. So let's execute this. You will get. So as of now, it looks like a max DOP. So initially we have set it as 0. So for this procedure, it requires that much max DOP program. So after this execution, you will get a feedback eligibility. So how the step for that same code. And also meanwhile, I'm just executing or All right, we will see that meanwhile the execution happening. So what should we need to consider uh, for this DOP feedback? So is to increase the overall concurrency and reduce the weights. So increase the query elapsed time, only the verified feedback is retained. So if it is not so, it won't. And so if it is adjusted, DOP leads to performance regression. So that a DOP refers as the last one. So if it is user cancel the query or a queries or something, considers a regression in this context. So this is the main thing need to be considered here. So it does not recompile the plans afterwards. Think it will take so much time to execute because of the processes which I have now. So this is how you will get to know that how much max DOP for this query for execution count. So the previously I have manually run the query, so we got 8 max DOP got right. So as for now. So in the text event, you came to know that what are all that queries and their CPU time, so which has been utilized for this particular procedure or something. So you will get all the details in that detailed session of that extended events. You came to know. So here main thing is this, we do not touch that code to modify or recompile the data queries. So here automatically senses that. So and it will automatically allocate that max DOP level for each query and it runs accordingly. So let me jump into the another topic, which is that cardinality estimation feedback. So the cardinality estimation feedback is the process which is the query optimizer estimates total number of rows processed in each level plan. The main thing is that SQL Server optimizer estimation of the number of rows going to be written versus the actual number of rows that has to being written. So for example, if you are giving that 100 rows going to return, so if it is 1 rows written, it's not a good thing, actually it's bad. So it will heavily depends upon the statistics. So here, which is that histograms creating during the index of the statistics creation. So the logical query rewrites and determines the cardinality. So in 2022, so what is that beneficial of this? So actually, C feedback will is the one of the intelligent query processing features. So which is mean that's using model assumptions. So gives a better fit for a given a query and the data distribution. So how much the data distributed data which you are providing. So accordingly based on that it will provide you. So main focus of this plan is to identify the estimated number of rows significantly deviates from the actual number of rows, applying the feedback with the model estimations to make a alternative viable models to try. So here is a short of thing. So how C feedbacks work. So basically it operates on the continuous learning by adapting, determining more suitable cardinality estimation assumptions. So with that, along with that, so the accuracy of the recurring queries it will evaluate. In the assumption appears to be incorrect, subsequent execution of the same query involves in the testing with the model assumption. So the effectiveness adjustment is assessed by comparing that actual versus that estimated rows, which is previously mentioned. So It improves the quality of the query plan. So using that query in the query store, and along with that, so the adjusted model assumptions, performance regressions. So if the query is cancelled by user, a C feedback is not applied to the query. So this is also considerations we have to take. It enhance the accuracy of this cardinality estimation, resulting in improved query performance, optimized execution plans. So let me jump into the demo. I'm just opening the file, which I am looking. Yeah, for this demo, I have chosen that database. So I have populated the data along with that. So I will check that the compatibility. So what is right now? So I'm going to change it to okay, fine. So it's already changed. So I'm just going to clear the page in the query store. Question. I already created the procedure. So here the extended event. So here also the extended event. Yeah, so this is an event. So you can watch the live data execution. So as a pointer, no data executed, query executed. So I'm just going to execute this procedure along with this. Here we didn't get any benefit. I'm just executing this procedure for 15 times. I'm going to run for one more time. Yeah. We got that feedback. So here is a feedback which shows you that selectivity of filter estimates. So if this is a hint it will provide. So according to what, so just running this procedure. It will do the validation. So in this validation, see here, you can see the CPU time. So here it looks like a 2463. So the feedback validation provides you that drastically like a 1778. So meanwhile, you can also check through this query feedback. here you got that verification passed and it applicable for that procedure which I have ran for the third time with that execute this SP demo CV. So it suggested the feedback accordingly that's that execution. So now I'm going to run that on more time. So so whenever that procedure hits, you will get like this like analysis and the validation part will happen on that seeing feedback. So accordingly, it will provide the feedback. As for now, in case of ours, so it provides that hint to assume that means activity of the for the filter, which we are choosing that procedure with that query. So here that verification pass and it applicable. So we have that query hint ID along with this. Along with the query hint text so that we used to know that this is applicable here. Yeah, this is how this CP pack will works without touching any codes. So here also without recompile, so it will automatically sense that this has to be applied and it does this activity. Mostly it will depend upon that statistics. So another thing which need to be considered here is that mostly the same will based on working on these techniques. There are three techniques which is implemented. So the top predicate independences correlations along with that joint containment assumption, which is simple and based report. So here is the predicate independence. So the below query which represents that in the conditions which you have that different set of values. So it's fully correlated. So this is one of the examples. So in the joint containment, so we have that fully correlated in a simple containment. So which is that first estimate filters and then join. So in the base containments, it's vice versa. So it deviates here. So the role goal. So as you see the below query, which is the top one of the value which is taken from the table. So it's scanning that pages is enough or seek is needed. So the row goal is default and feedback can be disabled. Yeah, that's it. So is there any queries you can?
Mhm. Thank you, Manoj. The session is really good. So we learned a few things on the 2022.
Thanks.
Yeah, Manoj.
Yes, Manoj, thank you very much.
Yeah.
Yeah, guys, is there any question, guys? You can ask it down. Yeah, I think it's the questions time. Yeah, okay, guys. Thank you, guys. Thank you for attending the webinar. And I hope you guys got some idea about the SQL Server 2022. And I could encourage to visit our website geopits.com. And we're still gonna be updated for upcoming webinar. I think, guys, I'm gonna see you all people for the next webinar also. Thank you, guys. See you all people. Yeah, thank you. Have a
Thank
nice.
you. Thank you. Have a nice day.
Yeah, thank you. Thank you.
Thank you all for joining this evening.